We will now explore how we can use the concept of pointers, memory locations, and dereferencing pointers, so going to the actual memory locations, in order to have access within a function to variables that are declared elsewhere and be able to change those variables from within the function. So let's suppose we'll have the user enter an integer and we want to multiply that by 2 via a function. So it's something very simple. So we need an integer, let's call it n, and let's have the user enter that integer. Please enter an integer. And then we need to scan that with a %d because it's an integer, ampersand n, so that allows the user to enter the value for n. And then we want to call this function, let's say it's called times 2, and we need to figure out what we're going to pass to that function. If we pass n to it, then that's just a copy of n that will be passed to this function. And we can do whatever we can try within the function. It won't change the value of n in the main function. And let's start there. Let's just do this for now. And then printf in the main function, the value of n is %d. And that's my n. So I want to see whether anything changed. Probably also print out what the user entered. So how about we print out here in main, you entered %d. There we go. And as you noticed, I put this in main into my printf statement so we know where the printing is happening. So next we need to write this function times 2. So what's its return type? What does it return? Well, we just want to multiply n by 2. So that's how about we have no return value, just a void return type. And for now, we're simply passing a number into it. And then we want to multiply that number by 2. So let's first print out the value we received. So in the function, the number is %d. And we print that out. Then we multiply number by 2, so num equals num times 2. And print out the new value in the function. The number is %d. Or how about we even say the new number? And that's about it. So that's my function. And all I now need is a prototype for this function. I put that at the top with a semicolon behind, and we don't need to have the variable name, but we could leave it there if we wanted to. Let's quickly compile this and run this step by step. Uh-oh. Please enter an integer. Oh, there's a colon instead of a semicolon. There we go. Let's run this. So n is declared. The user is asked to enter an integer. Let's put in our 42. And there we go. N changes to 42. We're printing out you entered 42. And next, we're going into the function. So in the function, a new variable is declared named num. And num receives a copy of what's stored in n. So num also has the value 42, but num and n are two separate variables. In the function times 2, the function doesn't know of n. It only knows its own 42, which is stored in num. So a copy of n is made and stored in num. That's what happens when we call a function and pass an argument to it by value. So the function now prints out in the function the number is 42. We multiply that number by 2, so you can see num changes, but n didn't change. N did not get updated because num is a completely separate variable from n. And in the function, we print out the new number is 84. And the function terminates, so we return to the main program. And in the main program, the value of n is still 42. It has no idea that we multiplied anything by 2 in the function. So if we wanted to modify the value of n within this function times 2, we need to pass the address of n to the function. So instead of calling times 2 with n, we need to pass the address of n to this function. And so, of course, we need to then modify the function. This wouldn't work anymore now. First of all, our prototype we are now passing an address. An address is something that's an integer with a star. That stores an address. So that's what we need. And then similarly down here in the function definition, we need to have an address. Num needs to hold an address, and let's call it numptr so we don't get confused. A pointer to a number. So numptr is an address of an integer. And so now that we're in the function, the number is, in order to print out the number that is stored at this memory location, we need to dereference numptr. How do we dereference numptr? We put a star in front of it. So star numptr goes to the memory location stored in numptr and dereferences it, reads out what's stored in there, and interprets it as an integer. Also now, num doesn't exist anymore. We have a numptr. It wouldn't make sense to multiply the pointer by 2. The pointer stores an address. Rather, what we need to multiply by 2 is what's stored at that address. So we need to dereference the pointer and multiply that by 2. And then we can print out the new number, ptr. We should look at this step by step when we run this code. All right, n is declared, and we're asked to enter an integer n. Let's enter our 42. And there it is. So n now holds the value 42, and we're going to print out that the user entered a 42. So you entered 42, and times 2 is called with the address of n. So the address of n is passed into the function. So now a new variable exists in my function, which is my numptr, and it holds the address of n. The address of n is fffc. N is from the main function. But now my function times 2 knows of n, sort of, kind of, because it knows the address of n, fffc. So numptr is a variable that only exists in my times 2 function, but what's stored in that variable is the address of n. We can now dereference that address and print out what's stored at that address. And that's what we do. In the function, the number is 42. So we just dereference numptr, and we're able to read out that value n. Next, we're multiplying the dereferenced numptr by 2. So watch what happens to n when we execute this next line. N changed to 84. So by dereferencing the address that points to n and multiplying that by 2, we were able to change n from within the function. And so now we can print out in the function the new number is 84, but even once we return to the main function, n has changed forever and ever. N now has this new value 84. So my function was able to change the value of n because we passed the address of n to the function. And then the function had access to that value of n by dereferencing that address. So this is an entirely super important concept. It's a little difficult to understand. So ideally, you'll just now play around with this code, change the function to do something else, and watch what happens in memory so that you can become more and more familiar with the concept of pointers and dereferencing them.